Did you know that artificial intelligence has been around since before the internet? Most people are surprised to hear that. We tend to think of AI as something brand new like ChatGPT or self-driving cars. But the earliest form of AI actually dates back to the 1950s, and it was called rule-based AI. So what was it? Rule-based AI was built on simple, if this, then that logic. It didn't learn or adapt. It just followed a fixed set of instructions, kind of like a digital flowchart. Here's what that looked like in real life. Think about early tax software like TurboTax in the 90s. You'd enter your info, and it would walk you through the tax process based on a huge list of rules written by experts. No learning, just following directions. Or those old phone menus, press 1 for your balance. Press 2 to make a payment. That's rule-based AI. It doesn't understand you, it just reacts based on what you press. Even thermostats work that way. You'd program it to turn on the heat at 6 a.m. and off at 10 p.m. Every day, it followed that rule. Rain or shine, it didn't adapt. Back then, this was cutting-edge stuff. That's why it's important to understand this history. Today's AI doesn't just follow instructions, it learns, adapts, and even creates. Knowing where AI started helps us better understand what makes modern tools so powerful and how we can teach our students to use them responsibly. After rule-based AI reached its limits, the next major breakthrough came in the 90s and early 2000s with something called machine learning. This was a game changer. Instead of relying on someone to write out all the rules, machine learning allowed computers to learn from data. That's the big shift. We started giving AI tons of examples and letting it figure things out on its own. A good way to picture it is by thinking about how we teach a child to tell the difference between a cat and a dog. With rule-based AI, we try to explain it using specific features, pointy ears, fluffy tail, that kind of thing. But with machine learning, we just show them a bunch of pictures and say, these are cats. These are dogs. Over time, they pick up on the patterns even if we never explain exactly what makes one different from the other. You've experienced this without even realizing it. Ever noticed how Netflix seems to know exactly what shows to suggest? Or how YouTube lines up the next video you didn't know you wanted to watch? That's machine learning at work. Those systems aren't following a list of hard-coded rules, they're learning your preferences based on what you've watched and adjusting their suggestions over time. In education, this kind of technology led to early adaptive learning platforms that could change the difficulty or type of question based on how a student was doing. It was the first step toward personalized digital learning, not because someone planned every step ahead of time, but because the system was learning from the student's behavior. Machine learning didn't give AI true understanding, but it was the moment computers began to recognize patterns, make predictions, and improve without human instruction. It's the foundation for everything that came next, including deep learning and the generative AI tools we're exploring today. By the 2010s, AI took another major leap forward with something called deep learning. Deep learning is a type of machine learning that mimics how the human brain works. Instead of relying on simple patterns, it uses something called neural networks layers of digital neurons to process and understand complex information. This allowed AI to do things like recognize faces in photos, understand speech, and translate languages with surprising accuracy. One of the best examples of deep learning in action is Amazon. When you order something on Amazon and it shows up the next day or even the same day, it's not just because they're fast. It's because deep learning helps them predict what people are likely to buy, where they're likely to buy it, and when they're likely to place the order. Amazon uses deep learning to manage inventory, stock warehouses in advance, and map out the fastest delivery routes. Their system is analyzing huge amounts of data shopping habits, seasons, locations, even weather, so they can stay one step ahead. In many cases, the product you just ordered was already sitting in a fulfillment center near your house before you clicked buy. This wasn't possible with rule-based systems. Deep learning made it possible for AI to do more than follow instructions. It could interpret the world, adapt to new information, and make smarter decisions. It set the stage for what came next, generative AI, where machines don't just react or predict, but actually create. Now we've arrived at the newest stage, the one most people are talking about today, generative AI. Generative AI first made headlines around 2022, but it builds on decades of progress. Unlike earlier AI, which focused on following rules, spotting patterns, or making predictions, generative AI does something new. It creates. This is the kind of AI that can write essays, generate images, compose music, draft lesson plans, answer questions, or even hold conversations all in real time. So, how does it work? Generative AI is powered by something called a large language model, or LLM. These models are trained on massive amounts of textbooks, articles, websites, and they learn the structure and flow of language. They don't just memorize facts. They learn how to respond based on patterns in human communication. That's how tools like ChatGPT, Google Gemini, and Microsoft Copilot can generate thoughtful answers, brainstorm ideas, or simulate dialogue, often with surprising creativity and depth. The big shift here is that AI isn't just reacting to the world, it's actively shaping what comes next. You give it a prompt, and it gives you something new. And because it can generate endless variations, it becomes a powerful partner in writing, teaching, learning, and problem solving. Of course, this also raises new challenges around accuracy, bias, and responsible use. But it also opens up huge opportunities, especially in education, where generative AI can support students with writing, tutoring, idea generation, and more. If rule-based AI was about logic, and machine learning was about patterns, and deep learning was about perception, then generative AI is about creation. And it's happening now. Generative AI is a transformative force we can't ignore. We're living in the middle of a major shift, and generative AI is at the heart of it. This technology is not just another digital tool. It's something that will touch nearly every part of society, from healthcare to business, from entertainment to government, and especially in the field of education. What makes this moment so different is how accessible the technology has become. Almost anyone with an internet connection, including our students and instructors, can use powerful generative AI tools right now. Tools like ChatGPT, Google Gemini, and Microsoft Copilot aren't just in research labs. They're in classrooms, in homes, and on mobile phones. And because these tools can generate ideas, explain complex topics, assist with writing, solve problems, and even simulate conversation, they're already changing how we teach, how students learn, and how we all engage with knowledge. This isn't something that's coming someday. It's already here. As educators, we can't afford to ignore this moment. We're not just observers of change. We're leaders in how this transformation plays out in learning environments. If we choose to embrace it thoughtfully and responsibly, we can help shape a future where generative AI becomes a tool for creativity, equity, and deeper learning. This is not just a trend. It's a turning point.